The construction industry in the United States is renowned for its impressive speed, far surpassing countries like Brazil and Argentina. In Brazil, a team of 2 workers typically builds around 17 square meters per day using traditional masonry methods. Meanwhile, in the US, a pair of workers can construct 40 to 50 square meters daily, thanks to the use of prefabricated materials and more efficient techniques. However, when it comes to even faster construction, China exceeds all expectations. In a remarkable achievement, the country built a 57-story building in just 19 days. And that's not all. During the COVID-19 pandemic, China constructed a fully operational hospital in only 10 days as part of its rapid response to the health crisis. How does China achieve these extraordinary feats? These accomplishments are no coincidence. They result from advanced technologies, highly efficient planning, and innovative construction methods. Now imagine building a house not in months or even weeks, but in just 7 days. In China, this is already a reality. Masonry and construction, a global perspective. Beyond Brazil and Argentina, many countries rely on masonry as the predominant construction method. In Europe, this technique is widely employed in nations like Portugal, Spain, Italy, and France. The preference for masonry in these regions is influenced by a combination of factors, including climate, material availability, and cultural traditions. Masonry is valued for its high durability and strength, characteristics that are especially appreciated in these areas. However, it's worth noting that construction preferences can vary significantly within each country, depending on regional specificities and available technological advancements. Masonry is a widely used construction method based on the layering of units such as bricks or blocks, bonded with mortar to form structures like walls and columns. This technique is recognized for its durability, strength, and versatility. Within masonry, there are 2 main categories: conventional masonry and structural masonry, each with distinct characteristics and applications. In conventional masonry, also known as partition masonry, the building structure is supported by independent structural elements like beams, columns, and slabs, typically made of reinforced concrete or steel. In this case, masonry walls primarily serve to enclose and divide spaces without contributing to the building's structural support. Materials used include ceramic bricks or concrete blocks, bonded with mortar, and this method offers several notable advantages. Its ease of execution is a key benefit, as specialized labor for this type of construction is widely available. Additionally, it provides flexibility for future renovations, allowing for modifications like wall removal or the creation of new spaces, as well as architectural versatility, enabling large spans and adaptable designs. However, there are disadvantages to consider, such as higher waste generation during construction, longer execution times compared to other methods, and higher costs due to the need for additional structural materials like concrete and steel. In structural masonry, the walls themselves bear the building's loads, eliminating the need for conventional beams and columns. This system uses specific blocks, such as concrete or structural ceramic blocks, designed to withstand structural loads. Among the main advantages of this method are cost reduction, since the elimination of beams and columns reduces the need for additional structural materials, and faster execution, as the process becomes more streamlined due to the simplified structure. Structural masonry also generates less waste, making the construction process more efficient and sustainable, while allowing for better planning and execution. On the other hand, it has some drawbacks, such as architectural limitations, as design flexibility is reduced, which can restrict personalized solutions. Renovations can also be more challenging, especially those involving wall removal due to their structural role. Additionally, there are constraints on creating large open spaces without intermediate columns, which can pose challenges in some projects. The choice between conventional and structural masonry depends on various factors, such as the type of project, available budget, site characteristics, specific building needs, and the availability of materials and labor in the region. Residential, commercial, and industrial projects can benefit from either system, as long as the decision aligns with the construction's conditions and objectives. Regardless of the chosen system, masonry remains an essential technique in construction. Its durability, strength, and adaptability make it a robust and reliable solution for a wide range of buildings, solidifying its status as a traditional and efficient choice worldwide. Wood frame construction in the United States. In the United States, the predominant construction system is wood frame, which relies on wooden structures to support buildings. This method involves assembling a primary framework of wooden beams, columns, and crossbraces, to which lightweight enclosure materials such as wood panels, drywall, or other options are attached. Wood serves as the main raw material for this system, chosen primarily for its abundance in the country and its advantages in terms of cost, construction speed, and sustainability. Wood frame construction is widely used in residential projects, particularly for single-family homes and small-scale buildings. While typically applied to 1- or 2-story constructions, it has also been employed in larger projects, including buildings up to 10 stories tall, especially in regions where wood is a common material. The core principle of this system is the use of treated wood to create the structural framework of the building. In a standard wood frame project, walls are made of wooden frames with spaces filled with insulating materials such as fiberglass or polyurethane foam, enhancing the building's thermal and acoustic efficiency. Roofs are also constructed using wooden frameworks, often covered with metal or wooden shingles, depending on the specific project requirements. One of the primary advantages of wood frame construction is its speed of execution. Wooden components are relatively lightweight and easy to handle, allowing for faster assembly compared to heavier systems like masonry or concrete. This results in significantly shorter construction times, reducing costs for developers and delivering completed buildings more quickly for occupants. Sustainability is another key strength of the wood frame system. Most of the wood used comes from reforested sources, contributing to environmental preservation. This makes wood frame construction a more eco-friendly option, especially compared to systems that rely on materials like concrete or steel, whose production processes have a greater environmental impact. Additionally, wood has the natural ability to absorb and store carbon during the growth of trees, making it an even more attractive choice for projects aiming to lower their carbon footprint. Another significant benefit of the wood frame system is its thermal efficiency and sound insulation. Wood is a natural insulator, helping to maintain stable indoor temperatures regardless of external weather conditions. This contributes to energy savings by reducing the need for artificial heating or cooling. The system also provides excellent acoustic insulation, as wood effectively dampens sound transmission, creating a quieter and more comfortable living environment. Moreover, wood frame construction offers greater flexibility for future modifications and expansions. Since wooden structures are lighter and easier to work with, alterations to buildings can be made with less cost and effort, allowing constructions to adapt to the changing needs of their occupants. This is particularly valuable in a dynamic housing market, where demands can evolve over time. For example, when a growing family needs more space or a homeowner decides to renovate their property. However, the system has its limitations. While efficient for small and medium-scale buildings, wood frame construction is not suitable for very tall buildings due to the limited load-bearing capacity of wood under heavy stress. This restricts its use in large cities with high demand for vertical construction. Additionally, climatic conditions can pose challenges. Although widely used in mild climates, wood frame construction may not be ideal for areas with high humidity or a risk of pest infestations, such as termites, which can compromise the integrity of the wood. In summary, wood frame construction is a widely adopted system in the United States due to its speed, cost-effectiveness, sustainability, and energy efficiency. It is particularly favored for single-family homes and low to mid-rise buildings, where the properties of wood are best utilized. While it has some limitations, especially for high-rise buildings or regions with adverse weather conditions, wood frame construction remains one of the most efficient and accessible options in the U.S. housing market. Modular and prefabricated construction in China. Although masonry is still used in some construction projects in China, it is not the predominant method. The country has gained recognition for its extensive use of modular and prefabricated construction systems, which rely on manufacturing structural and architectural components in controlled industrial environments before transporting them to the construction site for assembly. This system offers an industrialized approach to construction, prioritizing efficiency, sustainability, and speed. In the Chinese model, prefabricated components include wall panels, floor slabs, columns, beams, staircases, and even complete modules, such as bathrooms or kitchens. which arrive at the site nearly ready for installation. These elements are produced in highly mechanized and standardized factories, ensuring precision in manufacturing. The result is uniform, high-quality components that minimize human error and ensure compatibility during assembly. Once manufactured, the modules or parts are transported to the construction site, where they are assembled like a large puzzle. Thanks to standardization and pre-planning, the assembly process is extremely fast and less dependent on intensive labor. Equipment such as cranes is used to position components accurately, and connections between elements are efficiently secured using methods like mechanical fasteners or welding, depending on the materials and structure. This system offers numerous advantages that make it ideal for the Chinese context. One of the most notable benefits is the significant reduction in construction time. Projects that would traditionally take months to complete can now be finished in days or weeks. A striking example is the Huashinshan Hospital in Wuhan, built in just 10 days during the COVID-19 outbreak using prefabricated modules to quickly meet healthcare demands. Another remarkable case occurred in 2021 when a Chinese company constructed a 10-story building in just 28 hours and 45 minutes, employing a modular system that included integrated walls, floors, and internal systems. In addition to speed, waste reduction is a key benefit of prefabricated construction. Since components are manufactured in controlled factory conditions, materials are used more efficiently, generating less waste in the process. This contributes to the method's sustainability and helps meet increasingly stringent environmental standards in China. Cost optimization is another significant advantage, as mass production and standardization lower unit costs, particularly in large-scale projects, which are common in the country due to its high population density and rapid urbanization. The versatility of the modular system allows it to be adapted to various types of construction, including housing, hospitals, schools, and even mid-rise buildings. However, in densely populated urban areas where extreme vertical construction is required, modular construction is often combined with other methods better suited to high-rise buildings, such as steel or reinforced concrete structures. A crucial factor in the success of the prefabricated system in China is the integration of advanced technology. Factories use digital modeling tools, such as building information modeling, BIM, to design and plan each component with millimeter precision, ensuring seamless assembly on-site. Additionally, automation, artificial intelligence, and robotics are widely employed to accelerate production and enhance quality. In summary, China's modular and prefabricated construction system combines detailed planning, cutting-edge technology, and industrialized production to meet the demands of rapid urbanization. With its speed, sustainability, and efficiency, this model represents a revolution in the construction industry, standing out as an innovative solution to contemporary challenges in large-scale housing and infrastructure. Throughout this video, we've explored how different construction methods around the world are transforming the way we build our cities. In the United States, the wood frame system speeds up the process, while in Brazil and Europe, masonry remains the predominant choice. However, China stands out impressively with its modular and prefabricated approach, achieving feats like constructing 57-story buildings in just 19 days, or even hospitals in under 10 days, leveraging advanced technologies and precise planning. This relentless pursuit of innovation and efficiency is not just a trend, but a direct response to the urban and emergency challenges the world faces today. Now imagine a future in construction where time, cost, and sustainability are no longer obstacles but solutions. If you enjoyed this comparison of global powers, subscribe to the China or USA channel. Here, we'll bring you more videos like this, comparing strategies, innovations, and differences between the United States and China across various sectors. Don't forget to like this video and turn on the notification bell so you never miss an update. Join us to discover how these two nations are shaping the future of the world.